Okay. Yeah, yesterday I think we discussed something about the DHCP spoofing and snooping, right? So what is that? DHCP snooping, spoofing first. What is spoofing? Niresh?
Attacker manipulate the DHCP server.
Is going to manipulate the whole DHCP server. Sure.
Right.
Hmm?
Hello, sir.
No, ಹೇಳು.
Sir, the PAT configuration ಒಂದು ಸ್ವಲ್ಪ ಇದನ್ನ ಮಾಡ್ತಾರೆ.
ಹೇಳ್ತಾನೆ ಏನಿಲ್ಲ ಆಮೇಲೆ ಹೇಳ್ತಾನೆ.
ಕೇಳಿಲ್ಲ ಸರ್ ಅದು.
Okay.
Server tries to sign and access because
Okay. So what did I say? Like how we can mitigate this DHCP spoofing by enabling the DHCP snooping on the device. Okay, which device? The L2 device. Okay, how it's going to mitigate? How it's gonna stop that DHCP offer and DHCP acknowledge messages. to coming inside the network?
Port authorization.
Port authorization.
Trusted port.
Okay, so we are going to define which is a trusted port and which is untrusted port. Okay, wherein if it is a trusted port, then only it is going to accept the DHCP offer and acknowledgement messages. And if it is not, then it's not going to accept any kind of a message of DHCP related. Okay, now what we have to do, you just see here. If I go and check it here, and if I enable the DHCP, which IP address is getting assigned here? 100.0.0.11. Okay, where is 100.0.0.11? So this is my it is a rogue DHCP server. Okay, what is this? This is the attacker's server. Okay, and what is the IP address I have assigned here? It's 100. And what is the pool I have given? 100.0.0.11. It should start with what? 100.0.0.11. Okay, so if I enable the DHCP on all these devices, okay, what will happen? It's gonna take the IP addresses from the same 100.0.0.0 network. Okay, the first piece I have taken 100.1.1.11, second 100.0.0.12, and the third one will take it like 13. Okay, sorry, 14 is it took 14. Yes. So what I exactly want it from which device? The legitimate DHCP device. Okay, a legitimate DHCP server. But from where I'm getting? I'm getting it from the rogue DHCP server. Okay, that means he is able to, or he is successfully sending his DHCP offer messages to these end devices, and these end devices don't know who is the legitimate and who is a rogue DHCP server. So that means every traffic is going through this DHCP, that is rogue DHCP server. So in that case, what we have to do? What I said, we need to enable the DHCP snooping on the switch device. Okay. So first, do the same. So let's say like DHCP. Okay. So enable this one. First, enable the DHCP snooping, and for everyone, not only this one, DHCP snooping VLAN. Did we created any VLAN now? Did we created any VLAN? No, right? Then by default, VLAN one will be there. So we have to enable for everyone. Okay. So now we have enable the DHCP snooping. So now let's check like from where it's gonna change. Exchange the IP addresses from the rogue server or from the legitimate server. What it is getting? What it is getting? It's getting the APIPA. Why? Because whenever I enable the DHCP snooping on the switch, okay, every port will by default become what? Untrusted ports. Okay, so that is the reason it is not able to get any kind of a offer messages, even from the rogue server and or from the legitimate server also. Okay, so that's the reason every PC will be assigning itself with a APIPA, that is automatic private IP address assignment. Here also it will get with a 169.254, and on the last also it is going to get what? 169.254, because here also their DHCP will be getting paid. Okay, now what we have to do? We have to go on this interface. Which interface? Where it is connected to the legitimate DHCP server. Okay, but our legitimate DHCP server is into different network. Then how to get the IP address? I think I said you. If the DHCP server is into different network, what we have to do? What? What we have to? Which device we have to make it as a relay agent? The router we have to make it as a relay agent. So what is the command to make that one? IP helper address space, and then you have to give what? The legitimate DHCP server's IP address. Okay, on which interface I have to enable that one? G 0/0 or 1? 1? 0/0, for sure. I said like just find the interface where it is connected to local area network. Okay, and on that only you have to enable what? IP helper address. Okay, and I think I have already done. You can see here on 0/0 IP helper address is already enabled with a 10.1.1.1. You can see what is the IP address of this one, 10.1.1.1. Okay, so now go to this switch and interface faster than 0/4, and you have to say IP DHCP snooping, make it as a trusted port. That's it. Okay, now let's go and check from where it's going to take the IP addresses. Where it is taking? From 192, 168, 1.12. Let me show you the pool if you want. You can see here. What is the pool? 192, 168, 1.11 it is starting. Okay. So I think 11, it's been given with, it's already given 13. I didn't enable anything. So this is given with the 1.11. Okay. 1.11, 1.12 and 1.13. Understood? So this is how to what? Mitigate the DHCP snooping. Clear? Okay. So now what I said, what is the DHCP, sorry, ARP spoofing? What is ARP spoofing? Yes, Murali? Yes. What is ARP spoofing?
Attack from malicious attacker will be designed that
Okay. So what I said before coming into the network, what the attacker will do, he'll just take someone else's IP address. Okay. So let's suppose I have already 111 here. So already given to the 11. Okay. 192.168 1.11, and the gateway will be 1.10. Yes. So before coming into the network, what he's going to do, he's going to assign his own system's IP address with someone else's, and he's going to be connected in the network. That means unauthorizedly he is taking the access of the network here. Okay. So it is connected now. Okay. And this is also up. And if I try to ping the So ping 192.168.1.11, 1.12. Okay. I think it's failed. Yeah. is our dynamic is working here. So running, yeah, because of this is okay. Let's say no for that one. No IPR VLAN 1. Okay, yesterday I said like what is the binding table? Okay, so where what is there in that binding table? I said it will be the mapping of what? IP to map to the next what? Interface. Alright. So this is what the MAC address what we have, and then we have the IP address. And what is the lease time? What I said? Is that the same? 86,400. Yes. And after that, it is enabled with the DHCP snooping on the VLAN 1, and then it has a fast Ethernet 0/2. It has given with the IP address called 192.168.1.13. Okay. And what I'm trying to do, I'm trying to give the IP address. I mean, the attacker is trying to give someone else's IP address and try to enter. Okay. If you will see here, to IP interface. Right. So all are untrusted. Okay. Can you see any port which is trusted one? So that is the reason all of them they are getting as what? They are not getting the IP, sorry, the ping from, I mean, this is whenever it is trying to take one more someone else's device IP address, okay, and it's trying to ping with someone else. Okay, in that case, what's happening? What's happening? If you just go here, it is 11. Okay, so if you try to ping to the other one, say ping 192.168.1.12, okay, it will be pinging. But whenever it is untrusted, sorry, trusted one, in that case, if you try to assign the same IP address, which is having that someone else's, and in that case, this will stop pinging and this will be pinging to someone else. Okay, like 1.13 or 1.14 or 1.12, whatever it is, or even to the gateway. Okay, so that means what? The RP is stopping this untrusted ports to send or assign the same IP address because already having what it's having. I already know on this interface. On which interface? On gigabit Ethernet, sorry, fast Ethernet 0/3. I have been already connected with AE80, which is already having what? 192.168, 1.11. Okay, so I don't know who we are because I already have the same entry in my DHCP snooping winding table. Understood? So this is how it's gonna mitigate what? DHCP, sorry, ARP poisoning or a ARP spoofing, I can say. Okay, so you need to enter what? You need to say IP ARP inspection. Enter. Sorry, you have to give for VLAN also VLAN 1. Okay, so now it's gonna stop all this kind of, I mean, already all the interfaces of untrusted one. Okay, now you have to say which one is a trusted one. Fast Ethernet 0/4 should be the trusted one. So in that case, you have to go on that one. Interface fast Ethernet 0/4, and you have to say IP ARP inspection trust. That's it. Okay. If you say again, do show IP ARP inspection interfaces, you can see there only 0/4 will be trusted and remaining all will be considered as a untrusted one. Okay. Okay, this was something about the L2 security. One is DHCP spoofing and second is the ARP spoofing. Okay, and these were the two mitigating techniques. What are those? DHCP snooping and the DIA, sorry, DAI, dynamic ARP inspection. With the help of this binding table, what's they gonna do? They are going to check like, yeah, this is the interface what are connected with the IP address, and this is the MAC address of that one. If the same IP address is coming with a different MAC address, then it's gonna stop that traffic there on. Okay, clear? Okay. Now we'll go with the quality of service. Okay. So where you have seen this quality of service, I think we discussed something about this quality of service in some of the headers. What are those? Which headers? Hmm?
So the voice better.
Sorry?
Voice data is given the most priority.
Yeah. I mean, in which header I'm asking? UDP header. We have prioritization. Are you sure? In TCP and IP header. Okay. We have some fields like what? Service type. Okay. And here it is like something of quality of service only. Okay. We have the fields like in these two headers, TCP and IP. So as Murali said, like what we use this for quality of service just to maintain the quality of the network. Okay. For example, I mean, initial days, I mean, before some years ago. Okay. I hope you know that the telephone lines were totally different. telephone lines. I mean, the voice data used to go through the different network only, like the BSNL or PSTN, whatever they used to use. Okay, and the internet was it was totally having the different network only. It was a WAN network. But nowadays, what we're doing, we're sending everything through the internet only. Can you see any what do you call landlines nowadays in your home? No, everybody is talking mobiles, wireless. So where it is going through? It is going through the internet only. Okay. So if all the data which is going through the internet, then they are competing for what? The bandwidth. Yes. So before that, let us see like what exactly these two are. So I hope you have seen the IP phones. I have even shown you before. So what is that IP phone? Yeah, internet protocol phone. I know that. So with the help of a IP address, it's gonna work in the system and it will help us to send the voice data through what? Through the same internet where we are using to send the data also. Okay. So this IP phones use a VoIP, that is voice over IP technology to enable phone calls over the IP network such as the internet. Okay. And I hope even we discussed about the voice VLANs. Whenever we're discussing about the type of the VLANs, we discuss about voice VLANs. So what is that voice VLAN? What's a voice VLAN? It's a type of a VLAN which will carry the voice data, okay, which is generated by the IP phones. Okay, and now what we have done, we just taken all these technology into only one. That is, we are sending every data through what? Internet. It may be voice data, it may be video data, it may be the normal data what we are using here. Okay. So before, what they used to do, I mean, whenever they started using this IP phones, okay. So let's say this is my switch. Yes. So I don't know how many ports it is having. So just for an example, let's say I'm having an IP phone. Okay. So initial days, how were the IP phones were? It was having only one interface. Through that only it is going to transceive the data. Okay. And to power it up, we used to connect one more external cable to give the power to that IP phones. Okay. So if you have multiple, let's suppose some 10 IP phones in the office, then you have to use a whole switch here. You have to use what? The whole switch to connect all of them. Then where the other devices will be connected, like the computers or the PCs, where they should be connected. So that's the reason what they have done. They started using the PoE switches. What is PoE? Power over Ethernet switches. That means through the same switch, okay, it will allow us to transceive the power and data as well. Understood? So now what happened? This IP phones, they started having the 3 ports. Okay, one is what? The uplink, and second one is the downlink, and one is a internal switch, internal port I can say. Okay, you can see here initially the PSTN, public switch telephone network, okay, they used to send the voice data, but now we are started using what? VoIP phones. So VoIP phones have a internal 3 ports switch. Okay, one port is to external switch link. That means whatever the link which we are getting from the switch, okay, that is called as what? Uplink. And one more is what? You can connect a computer to that one. You can connect a computer to that PC. Okay. Can you see 3 ports here? 1, 2, 3. Okay. One is what? You can see here, which is connected to the switch, the middle one. Okay. And the third one is what? It will be connected to the PC. So we are extending the network instead of connecting separate to the switch. Okay. I mean, connecting a IP phone here and connecting a PC here. What we can do? You can connect a IP phone here. Okay. And to the same, you can connect the PC here. So that's the reason they will be giving 3 ports. Okay, so this is extra one, this is for auxiliary. Yes, it's not RJ45. Okay, which will be connected to the other one. So the second one is what? Which will be the uplink, and third one is which will be connecting to the PC here. Okay, even if you see here, that will be written. Yes, which will be supporting standard Ethernet, and then the fast Ethernet, and even the 1 gig Ethernet. Okay, and this one, that will also support the same standard fast Ethernet and the gigabit Ethernet. Okay, the middle one will be connected to switch, and the third one will be connected to PC. Okay, and one more will be there, it will be inside, it will be connecting to the same IP phone. Okay, if you can see it later. It will, if we give the power. For this, we have a separate, what do you call, application. Okay, we call it as a CUCM. It is not like if you just connect it and that will be done, you will start talking. No. Okay, you have to register this phone on the CUCM. That's a Cisco something is there. Okay. So on that one, you are going to give the number on that one, and you have to assign the IP address to that one. And through that only, it will allow to connect to the other IP phones via internet. Yeah. So one port is uplink, and second port is what? Downlink, and one connect internally to phone itself. Yeah, that's what I said you. Yeah, you have to assign the IP address to that one, but how you are going to call that? There should be a phone number, right? Yeah, that should be what you call registered on this. You have to register on this application. Okay, they call it as a CUCM. It's a Cisco's. If it's a Cisco's, then you have to register on this one. Okay. And this will also be having the separate network. And for this also, the network engineer will be, they will be separate. Okay. And place this voice and data traffic separate by placing them into a different VLAN. Then you may ask, like, if the switch is connected to via this PC via IP phone, then how it is going to send the data? We are going to keep the VLANs different here. So if I'm going to, keep this IP phone into the VLAN 1, sorry, VLAN 2, okay, I'm going to keep it into VLAN 10. Okay, like this. If we are going to place this PC and a IP phone in a different VLAN. Okay, where the voice VLAN will be untagged and the data VLAN will be tagged here. Yes. Next is what? PoE. You already know that it is a power sourcing equipment to power devices like what? IP phones, IP cameras, and the what is WAP? Wireless access points. Okay. So it sends the required amount of the power to the PDs. PDs means what? Powered devices here. Okay. So this was something about the IP phones and the PoE. Next, we will see what exactly the history of this quality of service. Why we started using the quality of service. Yes. So here, voice and data traffic used to use entirely separate network before. Okay. As I already said you, voice they used to use this PSTN, public switch telephone network, and the data used to use the whole enterprise IP WAN. But now, in the modern days, all share the same IP network. They will share what? The same internet, just to send both voice and data traffic. But they have to compete for bandwidth to different for different traffic, which results in a delay. What happens here? If all are sent in a same internet, okay, what happen? If I'm having 10 Gbps of a bandwidth, okay, so every data will be competing for the bandwidth. Yes, if I'm sending the same data through the same cable, then what will happen? So voice data will say I'll go, and normal data will say I will go, and video data will say even I want the data here, I want the bandwidth. Okay, so that is the reason it results in a delay. Okay, with some delay, it is going to reach the destination. Okay, so to overcome this one, what they have done, they started using the quality of service. I mean, how they standardized the quality of this network. Okay, you can see here, quality of service is nothing but what? It's a set of tools used by the network devices to apply different treatment to the different packets. Okay, they are started giving some different prioritization or treatment to some data. For example, I already said you, the voice data will be considered as a highest one, highest priority data. And next is what? Video data. And the next is what? Normal data. Okay, why they started giving the voice data as a highest priority? Why? Because if I'm talking now, okay, and it is not reachable to the other end, do I need to talk it again and again? No, right? If I'm talking once, then that will be it. I can't do the same thing. That means the retransmission is not possible in the voice data. That is the reason, without any delay or without any loss, the voice data should be given first. And the same goes with the video also. Yeah, video can pause and you can see that one. Okay, but voice we can't do like that. So that's the reason the first priority will be given to the voice and the second one will be video and normal data. Normal data we can retransmit it if the packet is getting lost. Yeah. So to manage this quality of service, we have to manage some of the things. What are those? The first thing we have to manage is what? Bandwidth. Okay. First thing we have to manage what? Bandwidth. What is exactly the bandwidth is? It is the overall capacity of the link. What is that? It's the overall capacity of the link. Okay, that can send the data. And the units are like kbps, mbps, gbps, like that. Okay. And the quality of service will allow to reserve a certain amount of link bandwidth for certain traffic. Then how this quality of service is going to maintain the bandwidth here with respect to the voice and the video and the normal data. For voice, you can give dedicatedly 20% of the bandwidth. I mean, just for an example. Yes, it is totally up to you how much you want to give. Okay, and then for voice, then the normal traffic or a video traffic, you can give 20%, and then the remaining can be given to the 60%, like that. Okay, so like this, you are going to segregate or you are going to break this bandwidth into some parts, and you will be dedicatedly giving it to the different data what we have in the network. Okay. So next is what we have to maintain the delay also. We have a lot of delays here. Okay, like what? The amount of the time it takes to source to destination is called as what? One-way delay. So let's suppose like we have these two routers. Okay, and whatever the time it takes from, I mean, send the data from R1 to R2. This is called as what? One-way delay. Okay, obviously it is going to take the time, right? Yes, it is not like immediately it is going to reach the destination. No, it will take at least some seconds or milliseconds. Yes, and if the R2 is replying back to the R1, then that is called as what? Two-way delay. Understood? So this delay also we have to maintain here. And then we have processing delay. What is this processing delay? If here the data is coming inside this router, okay, the router is not going to blindly send all the data towards the destination, does it? No. So what it will do? It will check what is the destination IP address. Do I have that route in my routing table? Yes. If I have that one, then which is the best path here to send this data towards the destination? So this kind of processes will be getting done in the router here. So for this also, it will take some time. Okay. So that is called as what? Processing delay. And then the queuing delay. What do you mean by queuing delay? What do you mean by queue? Queue means what? It's a waiting. Okay, that means if the continuous data is getting, okay, the router, they are not going to process it continuously. So that's the reason what they will do. They will keep the extra data in the queue or the buffer region. Okay, so that means if I'm having a data here, and this kind of data will be continuously coming inside the router, then what it will do, it will process this packet and it will see what is the destination IP address and everything. Okay, and that will be like a processing delay, and it will send it towards the exit interface. Okay, and just to process and all this one, the remaining should be in the queue. Okay, you can see here what is queuing. The time a packet resides in the output queue of the router. Okay, before sending it out of the network, it has to be in the output queue. Okay, so just to process it and send it towards a destination. And then after that, serialization delay. What is this one? The time takes to place the bits on a wire. It is not like it's gonna send it like ones and zero. It has to be converted, right? How it is to be converted? It should be converted into electrical or a light signal or a radio frequency. For that also, it should be taking some time. So that is called as what? Serialization delay. Next is what? Propagation delay. So what is this one? It's a time to take, to travel to the source to destination. Again, after keeping that electrical signal or a light signal or a radio frequency on that output interface, it has to travel towards the R2. Okay, whatever the time it takes from R1 to R2, this is called as what? Propagation delay. So we have to maintain all these delays. Okay. And next we have jitter. What do you mean by jitter here? It's a time variation in the time delay to send packets. For example, the first packet at the 10 millisecond and the second packet at the 100 millisecond. For example, if I'm saying, hi, Dhiresh. Okay. For the first 10 second, if I say hi, and if I'm sending hi, and after 100 millisecond, the Dhiresh is reaching. Is that okay? Yes. After 100th millisecond, Dhiresh is reaching. Yes, I already said continuously hi Dhiresh. But at the destination, it is reaching like what? Hi, and it is taking a pause, and then it is saying it as a Dhiresh. It's not going to work like that. Okay. So that is the reason what the IP phones they will do. They'll be having their own buffer. Okay. So it is totally related to the voice. Jitter means what? Continuously sending the packets without any pauses. Okay, maintaining these pauses is what is called as what? Jittering. Okay, so IP phones will be having the jitter buffer to fix this kind of delay. And then we have loss. What do you mean by loss? It is a percent of a packet that do not reach their destination. Okay, it may be because of what? You can see here, you are sending 100%, and because of some reason, like what? Faulty cables or whenever any kind of a devices or hardware failure. Okay, so this will be reaching only up to 60%. Then what is the use? Yes, so which will be also by when the devices packet queues get full and start discarding the packets here. Okay, so we have to maintain all these things: bandwidth first, and then the delay, and then the jitter, and then the loss. Okay, to maintain what? Quality of service. Okay. So to maintain all of them, we have 5 things. These are the features of the quality of service. One is what? Queuing. Okay. And then we have to go with the, what is that? Yeah. Classification. Okay. And then the third one is what? Marking. And the fourth one is traffic shaping, and fifth one is a traffic policing. Okay, to have this quality of service, we have to maintain all of them. What is that? We have to maintain the queue of the data, and then we have to classify. We have to give the priority to the data, and then whatever the prioritized data will be there, we have to mark it as what? It is a prioritized, which is highly prioritized data. Okay, and when it comes to shaping and traffic policing, we'll discuss it at the end. Okay. Okay, if a network, first one is the queuing, that means if a network device receives a message faster than it can forward them out of the appropriate interface, then the messages are placed in a queue. What will happen? Let's suppose like I have a router, okay, where it is getting the data like in a 1 Gbps, 1 Gbps, but my link or a link which is connected to the destination, which can send it up to 100 Mbps. Then what will happen? Not data loss. This router is going to keep the extra data in a queue here. Okay. I hope you remember that I mentioned something about the window size. In which header? TCP header, sure. In TCP header, we mentioned up something about the window size. What it is used for? What is used for? To control the data flow. Okay. So what will happen if a network device receives a message faster than it can forward them out of the interface? Okay. So what it will do? It's gonna place that extra data in a queue here. Okay. So by default, the queued messages will be forwarded in a FIFO manner. What do you mean by FIFO? First in, first out manner. Okay. That means they have to wait for its turn. They have to wait for its turn. That means the router is going to say that please stop, please slow down. Okay, because my extra the what do you call the out interface, okay, where I'm connected with, that is only 100 Mbps, and you are sending me the data up to 1 Gbps. So please stop it. Okay, if the device where it is connected inside, okay, that will send this data for the same speed, then what the router is going to do? It's going to drop the tail here. That means if a if a queue become full, then the device will start to drop the new packets, and this is called as what? Tail dropping. I mean, if this device is sending the data continuously, okay, even though this router is trying to what? Control the flow here. So still it is trying to send, then what will happen? The extra packets will be dropped here inside the network only. Then for this network, this device is not going to get any kind of what? Acknowledgement. How it's going to get the acknowledgement? When it is not going to reach the destination. Am I right? When it is going to get the acknowledgement? When it's going to get the acknowledgement? When it reaches the destination device, then only the destination device will be sending what? The acknowledgement towards the source. Okay, I hope you remember the TCP header. Okay. So if the tail drop can, this tail drop can affect the TCP global synchronization. That's what I said you. What it's going to affect? It's going to affect the global TCP synchronization. That means it's not going to get any kind of a acknowledgement. So the TCP sliding window, it increase and decrease the rate of the transfer of the data as needed. You can see here, whenever the network congestion is happening, network congestion means what? If the traffic is increasing on the link where it is connected in between the source and destination, what it's going to do? It's going to have the tail drops here. At the source end only, it's going to have what? Tail drop. And when the tail drop is happening, it's going to affect what? The global TCP synchronization. For that one, what the device is going to do? It's going to decrease the window size here. What it's going to do? If the over network congestion is happening, it's going to decrease what? Window size. Okay. And if the device sees that whatever the link I have connected between the source and destination is totally underutilized, okay, then it's what going to do? It's going to increase the window size. So this will be the continuous process, increasing and decreasing. When it's going to increase, whenever the network link is underutilized, it's going to increase the link or the bandwidth or the data rate of transfer. When it's going to decrease, when it finds that the network congestion is really high on this link. Okay, so this is how it's going to maintain. I mean, when the packet got dropped, it retransmit and it will reduce the rate and it sends the traffic. Then gradually increase the rate again. The same thing I said you. When the queue fills up and the tail drop occur, all the TCP hosts sending traffic will slow down and the rate at which they send data. Okay. And after maintaining this queue, they will go for what? Classification. What is this classification now? It organizes the network traffic into traffic classes. Okay. I mean, it is a fundamental to the quality of service that gives the priority to the certain type of traffic. Okay, what it's going to do? It's going to treat the different data as a different priority. For example, this voice data will be considered as a VVIP, very important data. Okay, next is what? It comes to video. Next is comes the normal data. That's a normal person. It will not be given any kind of extra priority there. Okay. So what is classification? This is a fundamental part of this quality of service where you are going to give the priority to certain types of the traffic, and you have to, you have two types of traffic where to give the priority to. Okay. And it uses many methods to classify the traffic. It has many methods to classify the traffic, to give the priority to the traffic. What are like? One is the ACL. ACL means what? Access control list. So based on that one, it's going to either permit the data or it's going to deny the data. Okay. Here traffic which is permitted by the ACL will be given as a certain treatment and other will not be given. Okay. And other than this, the second method is what? NBAR, that is network-based application recognition. It performs a deep packet inspection. What it does? It's gonna perform deep packet inspection, not only up to layer 3, layer 4, it's gonna check it up to layer 7. Okay. To identify the specific kind of a traffic here. So when it reaches a layer 3 and layer 4, it will find two fields. What are those? You can see here. One is PCP and second is the DSCP. What is PCP? You can find it in a layer 2. You can see here in the layer 2 and layer 3 header, there are specific fields which are used for this classification purpose. One is what? PCP, priority code point. So this field of the Ethernet header can be used to identify high or low priority traffic, and it is used only when the .1q tag is used. Okay. What is PCP? It's a priority code point. In which layer it is used? It's used in a layer 2. This is where only you can find the Ethernet header, right? Yes. So in the Ethernet header, we have a separate field called as what? PCP. So this is where it's gonna define the traffic priority or type. Okay. But when it is used, only when it is using what? .1q tag, which is a one more tagging method or tagging protocol. One is ISL and second one is a .1q. Okay. And in the third layer, which is third layer? Network layer. So it uses DSCP, that is differentiated services code point. So this field of the IP header can also be used to identify high or low priority of the traffic. Okay, here in this classification, it's going to give what? Priority. Then how it's going to be marked? How it's going to be understood by the devices that this is a prioritized data. Okay, for that one, we use one more thing called marking. Okay, so before that, let me tell you this one, how it's going to give the priority here. So PCP, it's also known as what? QoS, class of service. So this is of just 3 bytes, sorry, 3 bits, and it uses some PCP values from 0 to 7. It uses some PCP values 0 to 7. So in which case it uses 0, in which case it uses other numbers. You can see here that defines the traffic type, but majorly use are 0, that is the default one, which carries the regular traffic with no priority. If the PCP value is 0 on one particular header in the Ethernet, okay, that is totally normal data, which doesn't have any kind of a priority. Okay, so this should be treated as a normal. Yes, and the other two are like, one is 3. 3 means what? Critical application service. And then the 5 one is what? If your packet is having the PCP value as 5, then that is a voice data. Okay, so these are used by the IP phones to mark call signaling traffic and for actual voice traffic here. Okay, 0 is for what? 0 is for normal data. Okay, where it doesn't have any kind of a priority. And 3 is for critical application data, and then 5 is for voice data. Okay. So what I said, what is marking here? What is marking? So marking in a quality of service is a process of tagging network packets with a specific identifiers to indicate their priority or class of service. When the prioritized data, it will come to the marking, what it will do? Yes, this is the highest priority data, and I'm going to give a tag to this one. And whenever it's going to traverse the different devices, they have to understand, yes, this is a very important data, and I have to send it first. I have to hold the other data and I have to send it first. Okay, with the help of this marking, it's gonna do that. So this marking will help the devices along the network path to handle the prioritizes packets according to their importance or required service level. Okay. So next is queuing and congestion management. Then how it's gonna queue and how it's gonna manage the congestion here with the help of some different methods we have. It's an essential part of the quality of service, and which is used of the multiple queues. Okay, which is used with the multiple queues. This is where the classification plays a role. That means the device that can match the traffic basis on a various factors and then place it in the appropriate queue. Let's suppose like after classification, what the classification will do? It's gonna prioritize the data. Okay, so let's suppose I'm having a queue of a voice here. This is voice data and this is video data. Okay, and let's suppose this is a normal data. Okay, this is voice, this is video, and this is a normal data. Okay, how we came to know that this is voice, this is video, and this is normal? Because of the classification and the marking. Okay, so however, the device is only able to forward one frame out of the interface at once. So here a scheduler will be used. What the scheduler will do? For this particular schedule, I have to take the one packet from this queue, and next schedule it will be taking it from the second queue and third queue, like this. Okay, so scheduler is used to decide which queue traffic is forwarded from next prioritization allows the scheduler to give the certain queues more priority than the others one. Okay, so to do this one, we have some scheduling methods. What are those? First one is what? Weighted round robin. I hope you heard about the round robin method, right? What do you mean by round robin? Ever heard? Okay, what is this round robin? Round robin packets are taken from each queue in order cyclically. What it's gonna do? First packet will be taken from the voice, second from the video, and third from the normal. So this will happen in a cyclical manner. Okay, first, second, third, and then this one, and then this one, and then this one, like that. Okay, so but weighted is, I mean, round robin means what? It's gonna take one queue from, sorry, one packet from the each queue. But what do you mean by weighted one? Here, more data is taken from the highly prioritized data queue each time, then the scheduler reaches that particular queue. So let's suppose when it is reaching the vice queue, instead of taking only one packet, it's gonna take 2 or 3 packets at the same time. Okay, because it's gonna keep it into the buffer. Okay. So that's what the weighted one. That means the 20% will be taken from this one at the same time, and here 10% and here 5%, like that. Understood? Then next method is what? CBWFQ, class-based weighted fair queuing. What is this? It is the popular method of scheduling using a weighted round robin scheduler while guaranteeing each queue a certain percent of the device bandwidth during the congestion. That's what I said. Every time it's gonna take certain percent of the data from each and every queue. Okay. Even if the voice or video traffic is having the guaranteed minimum amount of bandwidth, round robin will add a delay and jitter because they have to wait for their turn. It is not like they are getting it from every queue. Okay, this voice and video, they have to wait for what? This voice, they have to wait for this until this it will take the data from video and then a normal data queue. Okay, again this normal has to wait for voice and video, like that. Okay, so to solve this one, LLQ method is used. What is LLQ? Low latency queuing. Like here, it designates one or more queues as strict priority queues. This means that if there is a traffic in the queue, the scheduler will always take the next packet from the queue until it is empty. I mean, you already know that this voice data is totally highly prioritized. Okay, so what in the LLQ it will do? It's gonna take all the data at the same time and it will go for the next queue. Okay, so next it will go for the normal queue. So this is what happens in the, what do you call, low latency queuing here. But still, this will affect the other queues also. I mean, if that queue or scheduler will be taking the data from this voice data, the whole data, okay, at the same time, then video and normal data, they have to wait for some time. Okay, that means you may get a delay in these two. Okay. Online, is there anyone who is not sleeping? See, everybody is sleeping.
Yes, sir. Yeah,
Let me ask everyone. Jeet, are you there?
Yes, sir.
Oh, he's just woke up, I guess. Gaitra,
Sir,
she's there. Mr. Bosu, are you there?
Yeah, Arun.
Okay. So, not sleeping. It's okay. So now we are remaining with the traffic shaping and traffic policing. So that will be completing the quality of service here. So again, these are what the advanced features. Okay, again, obviously we are going to learn this in a advanced routing and switching. Okay, in CCNP and CCIE if you are taken. So, but in this CCNA, I already said you, it is totally a theoretical part. Okay, you have to learn how exactly the basic part behaves here. Yes. So first one is traffic shaping. Shaping means what? It's a quality of service mechanism that smooths out a traffic burst by buffering excess packet and transmitting them at the defined rate. So here it will be having a threshold value or threshold rate, I can say. Okay. For example, if the data rate is getting more than 1 Gbps, then what the traffic shaping will do? It's gonna buffer the extra data what it's getting. Okay, you can see here the traffic stays within that specific rate while minimizing the packet loss. I mean, if it is getting more than this threshold rate, then what it's gonna do? It's gonna keep this extra data in a buffer here. Yes. So it gives a buffer extra excess traffic. I mean, stores the packet temporarily when the traffic exceeds the configured data rate and sends them later. Just like what? FIFO, first in, first out. Okay. And smooths the traffic flow, like reduces the sudden burst of the traffic, making traffic more predictable. Okay, you already know that what is the data rate we have. So according to that, you have just need to maintain what? The window size here. Okay. And if it is getting excess of that one, then obviously it's gonna buffer the extra traffic here. And then use for outbound traffic, like typically applied on a traffic leaving the device or a network. Where you can apply this one? This will be applied at the outbound interface. Okay. And how exactly this works? Here it monitors the traffic flow using a token bucket algorithm. It uses an algorithm called what? Token bucket. Okay. If the traffic exceeds the allowed data rate, the access packet will be queued here. It will be buffered. Then the packets in the queue are sent in a when the rate drops below the configured threshold value. Okay, this is called as what? Traffic shaping. What is policing? It's totally out of this. I mean, totally opposite of this shaping. So instead of buffering, what it will do? It will just either drop the packet or it's going to mark it. Okay, you can see here. Traffic policing is a quality of service mechanism that enforces a traffic rate limit by discarding or remarking the packets. Let's suppose I'm having a voice data here. Okay, so that will be considered as the highest priority. Yes, and the threshold data rate is what? Only 1 Gbps. And during this transmission, it is crossing this one. Okay, then that voice data will be either dropped, you can see here, or discarded, or it will be remarked. Remark means what? It's gonna consider that data as a normal data, not a prioritized data. Okay, that is called as what? Remarking. Yes. So that exceeds the configured data, right? Unlike shaping, it does not buffer excess traffic. What we have seen in the shaping, it will queue or buffer the excess data, but the policing doesn't do that. Okay. So no buffering will be takes place here. It's going to drop the packets that exceeds the data rate or marks them with a lower priority. For example, changing the DSCP or PECP values. And strict enforcement will be there, like ensures the traffic stays strictly within the allowed data rate. Okay, I mean, it's gonna see that with the help of the same token bucket algorithm, it's gonna maintain the same data rate of transmission. And it is applied on both inbound and outbound traffic. It can be used for both ingress and egress traffic. And how exactly it works? Again, it monitors the traffic flow using the token bucket algorithm, and the traffic is exceeding the data rate. It's either dropped or a remark. Okay, so these are the 5 things what you have to maintain the quality in networking. Quality in networking. Okay, am I clear? Okay. 9K. So this is what the network automation is. You want to continue this one? I can. Okay. I know you don't want. I'll just go with the simple method. Okay, I'm just explaining this. 8 slides, that will be done. Okay. Sorry? Huh? Yes, sir. Okay, now tell me what is exactly the automation is. What is automation? Okay, automatically. Let me hook up these online people. Is there a Mayur? Mayur, are you there? If you can hear me. Okay, Murali, what is automation?
Oh, sir. Automation is means it's combining the work of the system, so like giving it predefined rules so that the automation works in process.
Come again?
I'm not getting how to explain it, but automation is a automating the processes without human interference, or that can be
Machine work instead of human work, sir.
Yeah. Okay. We are reducing the human intervention. Okay. Just to automatize the work here. Okay. So without the human intervention, we are you are giving the automation to the work here. Yes. So that's what the automation is. But how exactly this gonna help in the network automation? Okay. So let's suppose now we have these routers, continuously routers, they are connected. Okay. And how exactly you configure all of them? If I said you to configure all this router just to make the reachability with any routing protocol you can use. How we can do that? For the first time, what you have to do? You have to go on each and every router and you have to take the console of that one and you have to configure according to your requirement. Okay. But how this network automation is going to help us? With a single Python script, okay, what you're gonna do? You're gonna send the configuration on all the devices at the same time. Okay, at the same time, what you're gonna do? You are going to configure all of them, okay, within few seconds, I can say, with the help of writing some Python script. Okay, so this is how it's gonna help us, network automation. So for that one, we have to compare how it was and how it is. Okay, so we have some three planes here. Okay, plane means what? Which is where we are going to send the data or the commands or the management data. Okay, so what is first one? The data plane. What exactly this one is? I'll just show you here, data plane. So what is the data plane? It handles the actual forwarding of the data packets between the devices. Whatever the actual data will send between the devices, that is will be with the help of what? Data plane, which will be forwarding the data packets between the devices here. Okay. So the primary task of this which will help us to transmit the data based on the forwarding decision made by the control plane. What will happen here? It's going to take the commands from the control plane and it will send the data based on that control plane. Okay. Enforces the quality of service policies, applies the security filters like ACL, and handles the packet switching or routing. Okay. So where you can find this one? It can be found on the physical devices such as routers, switches, and the firewalls. Okay. For example, sending a packet from one router to another router based on the routing table. How we send the data? How we send the data from one network to another network? Based on the routing table, obviously. So this is where the best path we will be having. So based on that one, you are going to send the data. Okay. So when it comes to switching, how it will send the data? Based on the MAC address table. And if you have created any kind of a VLAN, so based on that VLAN database also, it will send the data. So this is all happening in the data plane. And to control all of them, we have one more plane called what? Control plane. What is the purpose of this one? It is responsible for making the decision about the network operation and defining how data is forwarded. Where the data is getting forwarded? In the data plane. But how they will send the data? So that will be done in the or decided in the control plane. Okay. So here it's going to calculate the routing tables using the routing protocols. For example, any routing protocol, maybe OSPF, EHRP, BGP, or a static or default, everything. Okay. And it's going to manage MAC address table and VLAN assignment on the switches also. Okay. And distributes the policies like what? Quality of service and the access control. So where you can find this one? It is typically embedded in a firmware or a software of a routers and switches. And in modern days, it will be there in the software defined network. What is SDN is? The SD-WAN you are going to learn in CCNP. The same thing you are going to learn. SDN, software defined networking. Okay, where it's a centralized network. Okay, where it is going to, what do you call control all of them, control the devices in a centralized way. Okay. And the last one is what? Management plane. So what is management plane? Where it's going to provide the tools and interfaces for network administrator to configure, monitor, and troubleshoot the network. Which are the management protocols we have? Management protocols to manage the devices, to access the devices. Okay, you can see here. This will facilitate the device configuration and the control. With the help of these protocols only, what you're going to do? You're going to take the access of the devices and you're going to troubleshoot and you're going to what? Configure the devices. Okay. So this management plane will help us to do the same. So here monitors performance and logs the network activity, and it will be integrated with the automation tools for a large scale network management. Like what? The interfaces like CLI, SNMP, REST APIs, or a web-based GUIs will be integrated with the network automation tools here. Just like what? Ansible or Terraform. Okay. So this is what you have to learn in the network automation. These two tools. One is what? Ansible, and the second one is a Terraform. Okay. So using the SNMP to collect the performance metrics from a router and configuring devices via SSH, web GUI, or a automation tools like what? Ansible. Okay. So these are the different planes we have here. Okay. And after this, you have to see like this is a legacy plane. What I said, the older network, what we used to use. For every data plane, we have a control plane. Okay. And to control these two, we have a management plane. This is the older network design. But now what we have, it is totally different. Now for every data plane, we have a separate management plane. Okay. And to control all of them, we have a control plane. This is what? The controller based network. This is nothing but the SDN, software defined network. Centralized, we will be having a control plane and we will be sending the data towards a management plane. So they will manage the data plane. Understood? This is what the software defined network looks like. Okay. So here we'll be having some APIs. What is API? Application. Okay, leave it. You can see here. Let's suppose this is my WLC. Just for an example, I'm trying to, explain this one. So these are my WAPs. Okay. In this, in the place of this WAP, you can connect the switches or routers, anything. Okay. And this you can call it as a SDN controller. Okay. And this is an application where you're going to monitor all of them. Okay. What will happen in the software defined network architecture? We'll be having a centralized controller. We'll be having what? Centralized controller. And if you want to send any kind of a policies or any kind of a configuration, you just need to go on the centralized device and you have to push them towards the end devices. End devices like what? Like what? Network devices, routers, switches, and then the WAPs and any kind of a network devices, firewalls. So these kind of devices will be connected in the forwarding layer. Okay. So they are called as what? They will be in the data plane. So this routers, switches, firewalls only help us to forward the data. Am I right? So this is what the forwarding layer. Next we have control layer. So this is where we have a control plane, okay, which will be controlling both application layer and the forwarding layer. Yes, with the help of some APIs, application program interface. Okay, so this side we call it as a northbound API. Okay, here we use REST APIs. Okay, and this is called as what? Southbound API. Okay, this is where we use what? The different tools like what? OpenFlow. Okay, we have something like that. Okay, so we'll see what are these two. There they are, northbound APIs and the southbound API. So here, interface between SDN controller and a application or a orchestration tool. It's what? It's the interface between the SDN controller and the application stack, what we have. Okay. So being on the application stack only, we are going to pushing all the policies or all the configuration towards the controller, and controller is going to send it towards the what? End devices like the data plane. Okay, with the help of again southbound APIs. So here it allows the external applications to query the network and program its behavior. That means here it enables the network automation, analytics, and the policy definition. Okay. So what kind of APIs we use here? That is a REST API. That means for network configuration tools or a traffic analysis software, we use a REST API. We have a separate explanation for that one. Okay, you can read it later if you want. So here the monitoring applications use the northbound API to gather real-time network performance data from the SDN controller. So having all the data from the SDN controller, it's going to analyze how every data plane devices they are behaving, how they are performing. Okay, so based on that one, again we have AI and ML here. Okay, we use two types of AI here. What are those? I think I already said you. Generative AI and the predictive AI. Okay, what is generative AI? It will help us, you can see here, it will help us to automate the task like configuration, documentation, and the network policy creation. Okay, automatically, I mean, collecting all the data from this SDN controller, what this generative AI will do, automatically it will configure the devices. You don't need to do anything. Okay, you just need to give the script, you just need to give the log which is connected from the end devices. So based on that one, it is going to automatically configure the end devices, and even it will help to maintain the documents like what logs and all. And then if you want to create any kind of a network policy also, it will help you with that one. Okay. And what is southbound API? Here the interface between the SDN controller and the actual network devices like what? Switches and router. Here it translates the high level policies into the device specific configuration. Okay. In the Python level language, okay, you are going to write the configuration, but that should be understood to the end devices like the routers and the switches. So that will be converted with the help of this southbound APIs. So we use kind of a OpenFlow or a netconf or a GNMI kind of a protocols here, just to convert those high level language into the configurations. Okay. So here it enables the controllers to manage a physical or a virtual network. And where we can use this one? It's an SDN controllers uses a southbound API to push routing policies to switches into the network here. Okay. And I already said you, it uses some two types of AIs. One is what? One is generative AI, second one is a predictive AI. So what the generative AI will do? It will help us for configuration generation, automatically it generates a devices configuration. And then it will help us to policy recommendation. I mean, based on the logs it is collected and the traffic optimization or analysis based on this one, it's gonna recommend some of the changes here. It's gonna recommend you. Okay, so being a network administrator, you have to take a call whether I have to implement this or not. Okay, after that, it will even give you the network documentation also. Okay, where it will create the accurate, up-to-date network diagram or documentation. Okay. Next is predictive AI. What is this predictive AI? To anticipate network issues and optimize the performance proactively. So based on the collected data, okay, collected data, what it's going to do? It's going to anticipate what may happen next. If I'm getting the continuous logs here and this particular interface is having higher traffic, okay, how should I control this one? Okay, so that will be prediction. That kind of predictions will be done with the help of this predictive AI here. And even it will help us with the anomaly detection. Okay, I mean, based on some unusual traffic patterns, it could indicate that potential failure or congestion or a security threats. And then it will give you capacity planning. And then, the future bandwidth and the resource you needs based on the historical data trends, and then proactive maintenance, and then the performance optimization. Okay, so these are what the two AI. With the help of this, other than this AI, it uses ML also. What is ML? Machine learning. So what is machine learning? Exactly. It will learn all the data. Okay, with the help of this learned data, it's gonna give the result however you want it. So machine learning in network operation to analyze the vast amount of network data and to improve decision making through some pattern recognition. The same thing he said. What it's going to do? It's going to analyze all the vast data which is collected from all the devices. Okay, and on behalf of that one, it's going to improve the decision making with the help of those pattern where it is recognized. So it will help us with the traffic optimization or a threat detection or a fault prediction or even the adaptive quality of service. Okay. And I said you it uses a API. API is nothing but what? As I already said you, application programming interface. It's a set of rules or protocols and the tools that allows different software applications to communicate with each other. Okay. So here API acts as an intermediary, enabling seamless interaction between the software system, devices, and the application here. So where we have seen the REST API between the SDN controller and the actual application layer. Yes. REST means what? Representational state transfer. Okay, you can read it here. What kind of authentication it uses. And next I have the two tools. What I said. What are those? Ansible and Terraform. Okay. So I'm gonna explain these two in detail. Okay. So Ansible, it's an open source. Ansible, it's an open source automation tool used for configuration management, application deployment, and a task automation orchestration. What it is used for? It's totally used for network automation. What it will do? It will manage the configuration, okay, and any application deployment in the network and automation task and even for the orchestration purpose. What are the capabilities of this one? First thing, it will maintain what or manage the configuration of the devices. So it will automate the process of setting up the and managing the configuration of the software and the hardware across some multiple machines. Okay. So the major difference between this Ansible and Terraform is like what? The Ansible need the infra already. Okay. Infrastructure should be there and then only this Ansible will be working. But when it comes to Terraform, it's a IAC. It uses a infrastructure as a code. Okay, we'll discuss. Next is it's an agentless operation. Like that means Ansible operates without requiring any kind of agent to be installed on the target machine. Okay, this will be installed on the SDN. Okay, where it communicates over SSH. SSH means what? Secure shell. And it will use a language called YAML. What is YAML? What is YAML? Yet another markup language for defining configuration, which is easy to read and write. Okay, we are going to write the configuration in the language called YAML. Yet another markup language. Next is playbook and extensible. So these are some different features or capabilities of the Ansible here. What is Terraform? Terraform is also an open source infrastructure as a code tool primarily used for what? Provisioning and managing the infrastructure across multiple services, which provides the infrastructure for cloud and on-premises also. Okay, which will help us to combine both. Both means what? The cloud infrastructure and the on-premises infrastructure. But when it comes to Ansible, it will either go for cloud or else it will go for what? On-premises infra. Okay. You can find some different key differences of this Ansible and Terraform. Ansible focuses more on a configuration management and application deployment after infrastructure is provisioned. As I already said you, first in the Ansible, the infrastructure should be there. Then only it will allow us to manage the configuration or a deployment of the application. While Terraform focuses on the infrastructure provisioning itself. Okay, it will help us with the provisioning infrastructure in the Terraform. And Ansible is agentless, making it simpler to use in a certain environment. Whereas Terraform is declarative language to manage the full life cycle of the infrastructure. Okay, where it uses a language called JavaScript Object Notation, JSON. It's a lightweight text-based format for storing and exchanging data, and it is really easy to read and write, making it widely used for what? Web services, APIs, and configuration files. Okay. So this is what about the network automation. Okay. Still, I have a lot here. You can read it if you want. I have explained like what is the differences between the traditional network and the controller-based network. Okay. And what is exactly network automation is and how it's going to impact the network management. Everything is there. If you think you can do it. Okay. Sorry. It's just for your knowledge. They may ask like, what is network automation and all. Okay. Okay, guys, we will end the CCNA here. Okay, not the class, CCNA. Yes, online. Gaitra, G, Mr. Bosu, Mayur, Swayam.
Yes, sir.
Yes, sir.
So today we have completed the CCNA finally. Okay. So you can continue with the next course now. Okay. So I hope we'll meet again. So till then, everybody take care and have a great life. Okay. Yeah.
Thank you.
Thank you, sir.